So we're going to do a little refresher on z-score. This is a measure of position that indicates the number of standard deviations a value is away from its mean. So we can transform any x value into a z-score. Very powerful here. So any value can be transformed into a z-score using the value minus its mean over the standard deviation. So it's the value minus the mean over standard deviation. Okay? So this table here is the standard normal table, the standard normal distribution, right? Now, this list is the cumulative area under the standard normal curve. Okay? Now, cumulative area is a fancy way to say area to the left. Okay, so area to the left. So emphasis here, guys. You need to know this. You might see this again. Area to the left means cumulative area. Okay, so as you can see from this table here, you got that dotted line down the middle. All the numbers on the left side over here are for cumulative areas to the left on the left side of 0, and all the numbers over here on the right side are cumulative areas. You can even see it from the picture for z-scores that are on the left side, on the right side of the 0 mark. Okay, so any z-scores that are on the right side. Okay, and remember, cumulative area, we always shade to the left. Okay, that's why it's shaded like it is there. So if you think about a normal distribution, a standard normal, 0 is in the middle, guys. Negative numbers are on the left, positive numbers are on the right. If I have a z-score equal to 0, that means the cumulative area, well, if half of it is shaded, that's 50%. That's why I have a z-score of 0 to be 50% there. Okay? So what we're going to do is we're going to find the cumulative area. We're going to practice this given the z-score. So I'm given z equals negative 1.12. Which side of 0 am I on? I'm on the left side. Negative numbers are on the left, positive numbers are on the right. So I'm on the left side of the chart. Okay? So negative 1.12. Now, how do I do negative 1.12? Negative 1.12, how am I going to do this? Well, if I look over here, I see my z's. Okay, I see the z's, but those look like just the first two numbers. So I'll look at the first two numbers. What are they? The first two numbers are negative 1.1. All right? So I go to negative 1.1 right here, and that tells me the row that I'm on. Okay? Then this second part right here, that O2 right there, if you think about it, that O2 is this O2 right here. So I look and I see, where do those numbers overlap? And they overlap. So 1.01 this way, and then O2 this way. So what is the number that overlaps? It's this number right here, guys. So that number happens to be 0.1314. Okay? So the cumulative area, the probability that z is less than or equal to negative 1.12, that is equal to 0.1314. That's the cumulative area. Okay? Why is it less than or equal to? If you do the shading of it, 0's in the middle. negative 1.12 is here. The z values are less than or equal to, I shade to the left. That's cumulative area, shading to the left. Okay? Next up, negative 0.93. So what am I going to do? I'm going to look for the negative 0.9. And then once I find that row, I'm going to look for the 0.03 row or column. Okay? So it's negative. It's on the left side. So negative 0.9 right there. And then the 3 right here. So I come down and over, and it looks like I get 1762. So 0.1762 is my answer. This represents the probability that z is less than or equal to 0.93. And in a picture form, 0's in the middle, negative 0.93 is here, and so this is area to the left. Okay? Now this next one, I should be able to do without a chart. Z equal to 0. If you think about it, 0 is always in the middle, right? So cumulative area is area to the left. This area we know should be 50% if it's in the dead center and it's symmetric, right? But we can go look it up. So I go for 0. I find negative 0.0. So I go all the way over. And I have my 0, 0, so I go all the way down, and I see that it's 0.5000. Okay? So 0.5000, that's 50% right there. That's the probability that z is less than or equal to 0. How do I know that it's less than or equal to? Well, if the variable is first, the variable is first, and it tells you which way to shade. Shade to the left. Okay, you see this inequality telling you to shade to the left. Okay? It only works if the variable is first, though, so make sure the variable is written first. Now, 2.1, how do I look that up? I look up 2.1, but then I don't have a 0 there, so it's understood that it's 00 for that second part. So this is a positive number, so I'm on the right side. So I know that my drawing here, 0's in the middle, it's positive 2.1, so I know I'm on the right side. So I know my area is going to be greater than 50%. So I go to 2.1, see if I can find 2.1. 2.1 looks like it's right there. So I'm on this row, and then I want the 0. 0 is the first one, so I come down. And I got, what, 0.9821. 0.9821. Okay, so that's my area shaded right there. That's the probability that z is less than or equal to 2.1. That's 0.9821. All right. Hopefully that helps out. Now, you can also do this in your calculator. If you do it in your calculator, let me see here if I can pull this up. So, pull out your calculator. Say you want to do second and hit the vars button for distribution, and then it's normal CDF. That CDF is cumulative distribution. Okay, the C stands for the cumulative. Now, I think, and I could be wrong, that the first thing is for the mean. The second, then I put a comma, 1 for the standard deviation, so I'll have a standard normal. And then I'm going to put my x value. Okay, so my x value here, I guess, let's say, let's do one that we just did. Let's do the 2.1, and we'll see how that worked. Okay, I've done something wrong. All right, so that gives me 0.11. So what have I done? Let's try this out. Let's try this again and see what happens. So normal CDF. Let's do 1. No, let's do 2.1 for our value. Then I'll do 0 for the mean and 1 for the standard deviation. See if that works. Okay, no, that's weird. All right, we're going to have to Google this. So when in doubt and you don't know what to do, Google it. Okay, so let's Google. So TI-84, okay, how to get cumulative let's do CDF, right? So CDF of normal. Okay, so how do we do that? All right, so we got easy steps. So I go in my var, I hit lower bound followed by a comma. That's not what I'm wanting. Let's try PDF, see if the PDF works. So PDF, see what that is. See what the inputs are. Okay, normal PDF, second var, that's what we did. Normal CDF, you must choose the normal CDF function, not the normal PDF. Do not ever use normal PDF, okay? So there's 4 important numbers, all right? So there's a lower boundary. So if you want all the numbers that are less than a certain value, your lower boundary, make it negative 1,000, okay? And then enter your lower boundary, and then the comma key, and then your upper boundary, comma key, standard deviation. R's for R will be an average of 0, and then standard deviation of 1, and then close it out. Okay, so let's do that. So let's try this again. So let's go back to our second distribution, and so I'm going to go to the CDF. Okay. And so a lower bound, let's do negative 10,000. And I'm going to put a comma. And I'm going to put, I guess, the 2.1 that I did just a little bit ago. I'll put a comma, 0 for the mean, and then 1 for standard deviation, and close it. And I hit enter, and I get the 0.9821. And I think that's what I wanted. Okay, the 0.9821, yeah. Okay, cool. So this is how it works. So in the TI-84, I'm going to do the normal CDF, and I do negative 10,000, and I put a comma, and I put the z-score, whatever it is, the z-score, not SOAR, okay? And then I put 0 for the mean, and I put 1 for the standard deviation, and I close it up. So the thing that changes is whatever number you choose to put in there. And so that's another way that you can use your calculator to get the numbers that the table actually gives you. Okay, to me personally, the table's probably the quicker way to do it. Okay, but that does give you a way to get the value, all right, for the cumulative area there. Now, there is a scenario where the z-score is not in the table. Okay, so I want to show you what you do. So when the z-score is not in the table, we use the closest entry. Use the closest entry if it's not in the table. So like if I have a z equal to 1.029, what is the closest entry? Well, it's either 1.02 or 1.03. Well, what's the closest one? It's the 1.03. Okay? But what if I have a z that's equal to 1.024? Well, the closest entry now, it's either 1.02 or 1.03. Well, the closest entry now is the 1.02. Okay? But what about z equal to 1.025? Which one is closer, 1.02 or 1.03? They're both the same distance away. So if it's dead center in the middle like this, it's halfway. What do? You have to average this value and this value, okay? So you go look up the 1.02, and if you go look up 1.02, you get 0.8461. And you do look up 1.03, you get 0.8485. So if it's halfway between, you got to average 0.8461 plus 0.8485. Average them, add them up, divide by 2. And what does that equal? That equals 0.8473. So this is what you do whenever it ends in a 5 here for that third decimal. All right? Now, what is the 95th percentile? Okay, what is the 95th percentile? So I'm going to take this and I'm going to make it a little bit smaller. Oh man, come on. So the question is, what's the 95th percentile of the standard normal? Right? So I go into my chart and I look for 0.9500. Okay? How do I know? Because the 95th percentile represents the point where I'm 95%, I beat out 95% of the competition, right? So I score higher than 95%. That's cumulative area to the left, right? So I want to know what the z-score is that has a 95th percentile here. So I'm looking for the 0.9500 mark in my chart. So I'll look over here and I see that I have a 0.9495 and a 0.9505. So it looks like it's split between the two. So what are those numbers? Well, it looks like 1.64 and 1.65. So it's between 1.64 and 1.65. So that gets me a 0.9495, and this gets me a 0.9505. So it's exactly in the middle. This is 5/10,000ths away, and that's 5/10,000ths away. So if it's exactly in the middle, what do I have to do? I have to average these two. And so the average is equal to 1.645. The reason I'm going into this z-score is this is a very important z-score. You're going to use this z-score more than any other z-score in the class. So you either memorize that the 95th percentile z-score is 1.645, or you have to play this game and do the math and average every single time. And you're going to use this like between 80 and 100 times for the rest of the class. So it's not going away, people. You're just going to keep using it over and over. So you need to know how to do this.